Alright, what'd you guys get for the jump start? Man, that's the number one of my answers. Y'all, all I want you to do is find the average.
2.5.
2 point... What?
2.5.
Close? Y'all, there's 4 zeros. So it would be like 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1. But instead of writing 1 3 times, we could just say there's 4 zeros, there's 3 1s, there's 4 2s, there's 6 3s. I'm running out of room. There's 1 4 and there's 2 5s. Okay, and then how many times are we taking data for the bus? How many different days did we do it? Look, here's all the days added up. How many days?
Wait, how many days?
How many days did they look at the bus? 20. So what's the number on top gonna be? Add it up. 43. That's 0 plus 3 plus 8. What's 3 plus 8?
11.
What's 11 plus 18?
29.
29 plus 4.
30. No, not 30. Yeah, 30 something.
33 plus 10.
43.
Alright, and then on the calculator that I don't have, what's 43 divided by 20?
2.15.
2.15 is correct. So you can expect the bus to be 2.15 minutes late on average, which actually isn't bad.
Right. My bus was an hour late.
If you ever been to Disney and stayed and you have to take the bus, has anybody ever done that?
Yeah.
Sometimes you'll be waiting a real long time.
Okay, really?
All right. Yesterday, did we have a worksheet yesterday? No. Okay, we did a quiz. Okay, good. All right. Get out your notes. And turn to spheres and hemispheres. I made a quiz for this also because we're going to try to do 2 lessons today. Alright, a sphere is just a ball and a hemisphere is half of one, right? And here's the 2 formulas for a sphere. 4/3 pi r cubed is the volume. And then 4 pi r squared is the surface area. And then if it's half of that, then half of the volume, if you multiplied 4/3 times a half, that would be 2/3. And then if you multiplied 4 times a half, that would be 2. But what gets exposed when you slice a sphere? A circle. So that's why you have to add this other pi r squared, because once you slice it, it's just not going around anymore. You've got that exposed circle, but 2 pi r squared is for the circle, and 2 pi r squared is for the lateral part of the sphere, and then the pi r squared is for the exposed circle part. So you can just put them together, and it's 3 pi r squared. So you're gonna have to know these formulas. We're getting there. I ain't done it yet.
When's our test?
Friday. You already got, practice test. Don't forget to give it to you.
Yeah, I forgot to tell you this.
Listen. All right, y'all ready to do this?
No.
I'm gonna go grab practice test while y'all get ready. I haven't taken it. Alright, y'all, let's look at the first example. I want you to find the surface area and the volume. So to find the surface area, we just use 4 pi r squared. We're going to use our calculators, obviously. So the surface area, is this up here?
Yes, ma'am.
Equals 4 pi, what's the radius?
10.
10 squared. So 10 squared is what? 100 times 4 is? So that'll be 400 pi. And then when you put it in the calculator, that would be approximately 1,256.6 in a surface area, so it's inches squared. I think these are actually easier than all the other ones.
You see that now.
It's easier. All right, let's do the volume. For volume, the formula is 4/3 pi r cubed. It's cubed because it's 3-dimensional. So we can plug in the same radius. So that'll be 4/3 pi times 10 cubed. Let's just go ahead and throw that in the calculator and see what we get.
I like 10 to 13,000. 100 times 100.
10 times 10 is 100. 100 times 10 is 1,000.
Oh.
So that'd be 4,000 over 3 pi. And in the calculator, that is
4,188.
0.8-ish inches cubed. Good job.
Yeah, that was amazing.
Y'all do the next one. What do you got to do first before you do anything?
Fine radius.
What is the radius?
11.
How'd you get that?
Half of 22.
Very good. I'm going to go ahead and put r equals 11.
You always want to find a surface area before you find the line, right?
Oh, it don't matter. Whichever way you're filling it.
You just be meter square.
For SA? Mm-hmm.
Oh.
Does the big sphere make you think about Epcot?
Yeah.
A little bit.
I like the bushes that's made out of the Disney characters. Like with the Pluto bush and all that. I like it.
I saw on the internet this morning that Pigeon Forge has got a ride now that's like Soar. Y'all remember riding Soar?
Yeah.
They got one at Pigeon Forge now. I'm so excited.
Wait, it's sort of one with, it's like a, you in that little
Flying with the
Flying.
snails and
This is
stuff.
what I'm talking about. When I told you I was in Paris.
Oh yeah. It's awesome.
Your feet
Fun.
hang off.
Yes, and it dangled. Feel like you.
I'm excited. All right, y'all. What'd you get for surface area?
What you said?
Hit me with it one more time.
1,520.
0.5. Good, y'all. Meters squared. Does anybody have a question about surface area? It's literally just plug it into the formula. All right. What about for the volume?
5,575.
All right. 5,575.3 meters cubed. Any questions about the volume? All right. So let's do an example with the hemisphere. It's just like with the sphere, but half. Except surface area, don't forget the circle. So to do the surface area, since we have to do the 2 pi r squared for the lateral area and the pi r squared for the circle, the formula is 3 pi r squared.
So all you need for these is the radius. All you need for these is the radius.
Yes, sir. Alright, so for surface area, we're going to use 3 pi r squared since it's a hemisphere. And for the volume, we're going to use 2/3 pi r cubed. And like Kelvin said, all we need is the radius. So that'll be 3 times pi times 7 squared. What's 7 squared? 49, which is approximately what on your calculator? Give me with that again, I'm sorry. 147 pi?
Yeah.
Alright, but what is that? Okay, so 147 pi,
461.8.
which is 461.8 centimeters squared. Alright, that's good. And then for volume, we took half of the other formula for volume. So that'll be 2/3 pi times 7 cubed. So what is 7 times 7 times 7? 343. And when you put that in your calculator, it is about, yes?
I see Bryson Weaver and Olivia Matthews in guidance with their laptop, please.
Yes, sir.
Thank you.
That would be approximately what?
Just the one class I need.
718.4 centimeters cubed. Good job. Does anybody have a question about this? Because we're about to keep on keeping on. Take the formula, plug in the radius, stick it in the calculator. Have y'all made index cards of some of these formulas yet?
No.
I ain't made index, but I've been studying.
Alright. Alright, the next lesson is about changing dimensions. So it's like if I found the volume but I doubled the size of everything, what would happen to the volume? Or what if I just changed the height? What would happen to the surface area? So we're going to talk about how to do that. It sounds complicated, but it's really not that bad, okay? Flip it. Alright, it just said make sure you begin with the original ratio or scale factor. And we already did a lesson on scale factors weeks ago. I don't remember when. If you get a scale factor, make sure you reduce it to the smallest that you can. Ratios of perimeters, altitudes, medians, and diagonals are all the same because those are linear. The ratios of areas are squared because they are square units. And ratios of volumes have to be cubed because they are cubic or three-dimensional units. So you just need to know that the ratio of volumes is cubed. The ratio of areas is squared, again, because that's square units. And all this other stuff is just linear units. Linear. This is 2D and this is 3D. So if I tell you that we have two cones and they are similar, which means their measurements are proportional, and the scale factor is 3 to 5 for those two cones, we're going to fill in this table based off that ratio, scale factor, whatever. Okay, so perimeter is a linear measurement, so it would be exactly the same, 3 to 5. Surface area. Area is square units. So you would have to take both of these numbers and square them. So instead of 3 to 5, if I squared them, what would it be? 9 to 25. Altitude is a linear unit. So that would just be 3 to 5. Slant height is a linear unit. I would just say feet, something like that. So the ratio would still be 3 to 5. Volume is a cubic unit. It is three-dimensional. So we'll have to take these numbers and cube them.
27 to 25.
27 to 125 is correct. Very good.
Wait, did we, for that one, we keep 9 and 25?
Mm-hmm. Yeah, we can't reduce it. There's nothing that'll go into 9 and 25. All right, look at this next one. It's 4 to 121. Can I reduce that in any way?
Again? No.
No?
Well, you get 30.25 if you.
All right, so what would the ratio of the sides be?
Side 4 to.
Oh, hold up a minute. What does it say? What kind of ratio did they give us? Surface area. So what is that? Units what? Squared. Can I reduce it in any way?
2 to 11.
2 to 11. How did you get that?
Unsquared.
You unsquare it by taking the square root. And you can only do that because that's the ratio of the surface areas. All right, so the ratio of the sides would be what? 2 to 11. The ratio of the perimeters would be what? 2 to 11. The ratio of the altitudes would be what? 2 to 11. The ratio of the slant heights would be what? 2 to 11. The ratio of the volumes would be what?
8 to 1,331.
8 to 1,331. Because you have to cube the 2 and cube the 11. Very, very good. All right, y'all ready to try some of this?
Maybe. Maybe not.
Does everybody have these if I scooch up?
Yes,
All right. All right, it says 2 cylinders are similar with a scale factor of 2 to 5. If the volume of the small one is 695, what is the volume of the large one? So first thing first, we've got 2 to 5, but we're talking about volume. So what am I going to have to do with that 2 to 5? Cube it. And when we cube it, that would give us 8 over 125. So we're going to set up our proportion. It says the small one is 695. They want to know the large one. So on the right side of my proportion, does that 695 go on top or on bottom? On top. Why?
I don't know,
It's the smaller one.
Okay.
All right, on bottom, I don't care whatever variable you want to use. Hit me with one. X it is. How do you solve a proportion? Cross multiply and divide. So we get 8x equals, what is 695 times 125?
86,000.
How'd you get 695?
It's in the problem. And then what do you do to get rid of the 8? Divide by 8.
To this one.
And you get x is approximately
10,859.4.
10,859.4. And its volume, so it would be centimeters cubed. I'm gonna put a box around this. We got a lot going on over here. All right, questions about that one?
Big number.
It is a big number. All right. Let's look at the next one. It says X is similar to Prism Y with a scale factor of 7 to 4. If the surface area, so for surface area, what am I going to have to do with that scale factor?
Square.
Square it. What's 7 squared?
49.
What's 4 squared?
16.
All right, so let's set up our proportion. 49 over 16 equals, it says, so this is X to Y, so X to Y. If the surface area of Prism Y, so where's that gonna go? On the bottom. It's on top, let's definitely use X. And then cross multiply and divide. and then y'all can tell me what you got. I'm gonna give you guys a little few seconds.
So we gotta see this today.
16,000
Ooh.
and 0.72.
Did you divide? 30?
Oh, no.
1,004.5.
Alright, so X is approximately 1,004.5, and that would be, what's the unit?
Millimeters.
Millimeters squared.
Wait, why did this number go on the bottom but the other one go on top?
Because they told us it was X to Y, and then this is Y. So the X is across from X, the Y is across from Y. Alright, y'all ready to look at the bottom one?
Not really.
Alright, so down here, they give us two figures, and they want us to figure out the scale factor of just the prisms, the area, and the volume. So what's the scale factor of the two prisms? It does not matter which corresponding parts you look at. So, give me one of the ratios. 20 to 12. We can definitely reduce that. What will 20 over 12 reduce to?
10 over 6 reduces to 5 over 4, 3.
5 over 3.
5 over 3. By dividing by 4. Alright, if that is the scale factor for the sides, what will the scale factor for the surface areas be?
Square.
25 over
25 over 9. All you have to do is square the 5 and square the 3. And what would the scale factor for the volume be? 125 over 27, which is 5 cubed over 3 cubed. Does anybody have a question about that part? All right, flip it. All right. So for changing dimensions, let me get a marker that's going to show up. First, you have to determine your base number. That's going to come from a word that's in the problem, like doubled or tripled or quadrupled, something like that. So if they said doubled, your base number would be 2. If it said tripled, and then multiplied by a fourth would just be a fourth, or 0.25. And obviously there's like infinitely many of these. I just picked a few. The second thing you want to do is determine the exponent. We just talked about this. If it's area, then what do you have to do with it? Square it. And if it's volume, you have to cube it. Alright, and then you plug the base in here, give it that exponent, and do the math. And that's what you're going to use. It's just the next page. Yeah, it's the same thing. We're still just changing dimensions. This is kind of like what we just did, but somehow even easier.
We're doing racist pancake today.
Everybody got this?
I can't run.
Alright, so let's look here. It says, if the dimension of a triangle are doubled, what does it have on the volume? What effect? Doubled means my base is 2. Volume means my exponent is 3. So 2 to the third is 8. So you would multiply it by 8. How easy is that?
I mean, okay.
Y'all do the next one.
What do you mean?
All right, it says tripled, so the base would be what? 3. And then it says the lateral area, so what would the exponent be?
Square.
No, yeah.
And then 3 squared is 9. So multiply by 9. Which would be 9 times greater, right? Or 8 times as big, whichever one. Alright, for these next two, we're just taking this and then actually doing the multiplying. You ready? Alright, so it says the surface area is 324 pi inches squared. Is this up here? Okay. If the dimensions are multiplied by a fourth, what is the new area? So our base is what number? A fourth. Good. And its area, so we will square it. So what is 1 over 4 times 1 over 4? Going straight across. Which is 1 over 16. Because 1 times 1 is 1, and 4 times 4 is 16. Now, all you have to do is take the original, which is 324 pi, and multiply it by 1 over 16. And just tell me what you got. All right, 63.6 and its area, so inches squared. If you wanted to know that as pi, that's 20.25 pi. Just in case you was curious.
Wait, how does that? Oh, okay.
All right, y'all do the next one. Are y'all doing this one?
Yeah.
Okay. Doubled volume.
This is a nice number.
Yes, it is. It's beautiful.
I feel like there should be more in
If it's doubled, what's your base? 2.
it.
What's your exponent if it's volume? 2 cubed is 8. The OG is 625. Multiply it by 8.
You get 5,000.
And you get 5 grand. Centimeters cubed. Flip it over. So this is going to be just changing one thing instead of changing everything. This is the most complicated. Alright, when all the dimensions change, that's what we just did. If I told you it was quadrupled and it was area, you would just say 4 squared is 16, so it'd be 16 times bigger. But here we're only changing one thing. So what you're going to do is write the formula, plug in ones for everything, and see what you get. Then the second time, you change whatever it's talking about, and then see what you get, and say how many times bigger or smaller. So let's look at this one. It's saying the height of a rectangular prism is quadrupled, and they want to know about the surface area. They're only changing the height. So I can't go and do this. It don't work. I'm not changing everything, only the height. So first, what is the formula for the surface area of a rectangular prism? Surface, 2 L W, good. Keep going.
2LH
Plus 2LH.
plus 2L. No.
2WH, good. So the first time I do this, for every L, W, and H, I'm going to plug in a 1. So this is the original, and I'm going to plug in a 1 for everything. So that'd be 2 times 1 times 1, plus 2 times 1 times 1, plus 2 times 1 times 1, and I'm positive you can do that in your head, but what number do you get? 6. The second time we do it, we're going to quadruple the height. So instead of plugging in 1 for the height, what am I going to plug in? 4. So that would be, I'm going to draw a line here to keep them separated. 2 times 1 times 1 plus 2 times 1 times 4 plus 2 times 1 times 4. And then what does that give us? 18. How many times bigger is 18 than 6? What did we multiply by? 3. So it's 3 times bigger.
So is that the answer?
That's it. Yeah, that's just the easiest thing to do. All right, let's do another one together. Can I scooch it? All right, thank you. All right, it's talking about the volume of a pyramid. So the formula for the volume of a pyramid,
1/3 base height.
1/3 the area of the base, big B, times the height. So we're gonna take the height and double it, but first, what are we gonna plug in for B and H? So when I plug in is this up here? When I plug in a 1, that'll be 1/3 times 1 times 1, which is 1/3. The second time, we're going to double the height. So what am I going to plug in for the height? 2. So 1/3 times 1 times 2, which is 2/3. Very good. So what do I multiply to go from 1/3 to 2/3? Times 2. So it's 2 times bigger. Or larger. Whichever word you prefer. Alright, for this one, the next one, is talking about the surface area of a sphere. So what is the formula of the surface area of a whole sphere? 4 pi r squared. Very good. The radius is going to be multiplied by 1/3. So the first time we're just going to plug in a 1 for the radius. And you guys, I just leave pi alone. I do not do the decimal for pi. So if you plug in a 1, that would be 4 pi times 1 squared. So 4 pi. Very good. The next time, I'm going to plug in a 1/3 for r. So that would be 4 pi times 1/3 squared.
So 4 pi, 1/9.
4 times 1/9 would be what? 4/9. Very good. So if I go from 4 pi to 4/9 pi, is it smaller or larger? Smaller. How many times smaller? 9. So this one would be 9 times smaller.
How do we get 9? I wouldn't even know how we got 4 to 4/9. So if I type
Like 1/3 times 1/3, 1 times 1 is 1, 3 times 3 is 9. And then you got that 4 over here. So multiplying fractions, no big problem. Top times top, bottom times bottom. You know, if you put it in the calculator and you get a decimal, how do you change it to a fraction? Math, enter, enter. Does anybody have any questions? All right, let's play quizzes.